Hello, YouTube. This is Umos03. In the previous lesson, we talked about pass by value, and we said that Java passes information by value rather than by reference. And so basically, instead of passing a direct copy of a variable into a static method, we saw a situation in the previous video where there was some unexpected behavior, and it seemed like a variable didn't get incremented like we expected it to. So anyway, in this video, I wanted to go ahead and review some of the pass by value techniques and also look again at concurrent hash maps and the different iterators that we have available to different data structures. And so what I've done, I got very formal about the documentation. I did a pretty good job populating the different methods in the class that we're going to talk about with Java docs. Okay, so anyway, what we can do is kind of study a little bit of this, but I wanted to start here. And so I'm just going to run the main method and we can talk about some of the fundamentals that we've had in previous videos. So I'm just going to go ahead and run the main method and we're going to compare it against the code that I wrote. Okay. So the first step, it just says I just printed some statements that we know to be true from recent videos. Okay, so ArrayLists represent a global collection of elements referenced by index positions. Linked lists represent a collection of nodes where each node references the next node, right? It's a fundamentally different data structure. Stacks represent a last in, first out data structure where we deal with the top of the stack only, right? Pushing and popping elements off the top of the stack, right? And queues represent a first in, first out data structure, like people in a supermarket where we remove elements from the beginning and add them to the end. And then hash sets represent an unordered collection of unique elements, no duplicates permitted. Hash maps represent a collection of key value pairs where each unique key maps to one value, okay? And then we talked about what the different types of iterators available to different data structures. And I wanted to correct something I said in the previous video, because in the previous video, I said that concurrent hash maps don't have any iterators available to them. It's actually the opposite that's true. They have all three types of iterators available to them. So anyway, ArrayLists get an iterator and a list iterator, okay? And we said again, a list iterator is better than an iterator because you can go in the reverse direction, and also because you can add elements to the underlying collection, to the underlying data structure, right? With iterators, you can only remove. With list iterators, not only can you go forward and backwards, but you could also remove and add elements to the underlying data structure. And so linked lists also get an iterator and a list iterator. Stacks get an iterator, a list iterator, and enumeration, according to the order in which you added the elements to the stack. Okay, so if you just iterate through a stack, it's not going to be the same as if you pop the elements off the top, right? If you iterate through the stack in the forward direction, it would give you the order in which the elements were added. I think we saw one example of that in a previous video. And then queues get an iterator only, hash sets get an iterator only, hash maps get an iterator on the keys and an iterator on the values. Then we talked about some legacy data structures. So vectors are just like ArrayLists, older data structure, but they also get an enumeration. So if anything, I think vector is a little bit better than ArrayLists. And then hash tables are just like hash maps. They're older, but they also get an enumeration on the values. So if anything, you might be better off with a hash table than a hash map. And then a concurrent linked queue is just like a queue, but it's just using a concrete class instead of, remember, if with traditional queues, queue is just an interface, and then you implement a linked list class. But then concurrent linked queue, that is the class that you declare and initialize. And then linked hash sets are just like hash sets, subclass, same set of methods. And then linked hash maps are just like hash maps, subclass. They don't get an enumeration like hash tables do. And then concurrent hash maps are just like hash tables. They do get an enumeration on the values, but remember, you have to go ahead and remember to import java.util.concurrent.concurrent-hashmap. So question one, ArrayList or vector, you get to pick. Question two, queue interface or concurrent linked queue class. Question three, hash set or linked hash set. And question four, hash map, hash table, linked hash map, or concurrent hash map. So there's 32 combinations, right? Because we only have one linked list and one stack, but there's 32 combinations if you wanted to have access to these 6 fundamentally different data structures. And so I recommend using a vector, a linked list, a stack, a concurrent linked queue, a hash set, and a hash table, and forgetting about ArrayLists, queue interface, hash maps, linked hash sets, linked hash maps, and concurrent hash maps. And so this is how you would create those 6. So vector of type X, my vector equals new vector of type X. And remember, you would have to go ahead and import the proper classes that you were using those data structures for. But then vector of type X, my vector equals new vector of type X. Linked list of type X, my linked list equals new linked list of type X. Stack of type X, my stack equals new stack of type X. Concurrent linked queue of type X, my queue equals new concurrent linked queue of type X. Hash set of type X, my set equals new hash set of type X. Hash table of XY, my dictionary equals new hash table of XY. Okay, and then we have a stack of type string. My stack equals new stack of type string. String first word equals my stack dot push of dog. So if you look in the API for the stack class, if you look at the push method, it says that it returns the item argument. So it returns whatever you're pushing onto the stack. So at the end of this operation, not only do we add dog to the stack, but dog is also assigned to first word. And then my stack dot push of cat, so that's going to go on top of dog in the stack, right? And then my stack dot push of steak, my stack dot push of zebra, my stack dot push of elephant. And then list iterator of type string blanket equals my stack dot list iterator. And then in old size equals my stack dot size. This will be 5, right? It's the original size of the stack before we really do anything with it, aside from pushing the elements initially. And then in S, so we're just going to declare an integer S. And then system.out.println of first word dot concat of first word plus first word. So these are the two different ways to concatenate two strings together. And so we just get dog, 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 right? Because we said dog was assigned to first word. That's what the push method returns. And then for S equals 0, blanket dot has next, S plus equals 1. So this is a Boolean that's going to be checked each run through the for loop. String D equals blanket dot next, system.out.println of D dot to uppercase. If S equals 0, blanket dot remove. So we're going to remove the first element from the stack. But other than that, we're just going to print each of the elements in the stack in capital letters. But you can see that it prints the elements in the order that we added them, not the elements that they would be removed, not the order that they would be removed, right? The order that they were added. Okay, and so that's a little different from removing elements from the top of the stack. It's a little different from fundamentally how a stack works. Okay, so if you say system.out.println of old size equals S, you would get true, right? But system.out.println of old size equals S minus 1, that would be false, right? Because both of the value of both of those variables would be 5, right? Because there were 5 elements in the stack. But we removed one of them, right? So S would be 5 and old size would be 5. But if you called my stack dot size, that would just be 4 because we used the iterator to remove the first element from the underlying stack. But then you could add the list iterator, right? Because we said list iterator of type string blanket. Okay, so blanket is a list iterator, and that can go in the reverse direction. So we went from the beginning of the list of the beginning of the stack to the end of the stack with the list iterator by calling next over and over again. But then we could go in the previous direction. So we could say, well, blanket dot has previous, string sun equals blanket dot previous, system.out.println of sun dot substring of 0, 3. So we talked in lessons 5 and 6 about string methods, and we saw that this would return the first 3 characters in each of the elements in the stack, but we would traverse it in the reverse direction, which is actually the way that you would remove elements from the top of the stack, is the reverse of the order in which you added them. So it would be ELE for elephant, because that was at the top of the stack, and then ZEB for zebra, because that was one down, and then SNA, and then CAT. And then remember, dog was removed, because we said in the previous loop, if S equals 0, blanket dot remove. So hopefully that's clear to you. And then system.out.println of my stack dot size equals old size, so that would be false. But system.out.println of my stack dot size equals S minus 1, that would be true, right? Because both of these would be 4. And then system.out.println of stack is a subclass of vector, so element at position 0. So it's just a reminder. Remember, if you look at the API, you see that stack is actually a subclass of vector. So all the methods from vector can also be applied to a stack. You wouldn't necessarily want to do that, but you could say my stack.get of 0, and that would give you basically cat because we removed dog. Okay, but it's not the first element you would pop off from the top, and so it would actually be the bottommost element. Okay, and then my stack.clear, system.out.println of my stack.empty, that would be true because that's a method from the stack class. But system.out.println of my stack.isEmpty, that would be also true because that's a method from the vector class, which is a superclass of stacks. So therefore, stacks can also use the isEmpty method. Hashtable of type string string, my dictionary equals new hashtable of string string. My dictionary.put of dog, awesome animal. My dictionary.put of cat, good animal. My dictionary.put of snake, awesome animal. So we're creating a hash table and adding 3 key value pairs to it. And then we have another hash table with 2 key value pairs. So hash table of type string string lonely dictionary equals new hash table of type string string lonely dictionary dot put of human boring animal lonely dictionary dot put of snake with sick animal. My dictionary dot put all of lonely dictionary. So again, it's a void method from the hash table class that accepts an input dictionary and adds the key value pairs from the input dictionary onto the dictionary on which the method is called. So enumeration of type string Vegas equals my dictionary dot elements. We said the two dictionaries that have access to an enumeration are a hash table and a concurrent hash map, not a hash map and not a linked hash map. Boolean first one equals true. While Vegas dot has more elements, if first one, so that's going to be true, right? System.out.println of enumeration. So it's just going to say enumeration here. And then we're going to say system.out.println of Vegas.next element. So it would basically enumerate on the values of the dictionary. And so we would just get awesome animal, good animal, sick animal, and boring animal, right? So hopefully, because those will be the 4 unique values in the dictionary. So hopefully that's clear to you. And then iterator of type string Dallas equals my dictionary dot key set dot iterator, right? And then you could say Boolean truck equals false, while Dallas dot has next, string current key equals Dallas dot next. If not truck, so that would be true, right? This Boolean would be true. System.out.println of iterator on keys using v equals d.get of k on the dictionary for the value, right? So that's what's printed here. And then again, you would just iterate through the values in the dictionary, but by calling my dictionary.get of current key. So I'm just showing 2 different ways to iterate through the values in the dictionary. You could use an enumeration, you could use an iterator on the values, or you could use an iterator on the keys and call the get method. So hopefully that's clear to you. But then you could go ahead and say system.out.println of my dictionary.isEmpty, right? And then if you were calling Dallas.remove over and over again, if you were using the iterator to remove each of the key value pairs in the hash table, then eventually the isEmpty method will be true, right? So hopefully that's clear to you. And then in the previous video, we also talked about pass by value. And so I wanted to go ahead and review that in this video. So hopefully you're following along. And we're going back and forth between the code and the output. And now we're here. Okay, so we're creating. So what we're going to do, we're in a class right now. We're in a class right now called renewal. Okay, so it's a class called renewal. And I have some different methods, and I think I showed the Java docs briefly at the beginning of this video. But we have a string water equals waterfall, and then object t. T equals new renewal of water. So this is an example of polymorphism, right? We said object is a superclass of every class. So you could declare something as an object and initialize it as any other class, right? Because object is the superclass. But we said eventually, if we want to use the methods that show up in renewal that don't show up in object, then eventually we would have to explicitly cast t to a renewal object. So we say object t equals new renewal of water, but then renewal u equals renewal of t. So u is like actually a renewal object that can access all the methods from the renewal subclass, right? And then system.out.println of old string, and then we would just get waterfall, right? And then we're going to say renewal.try concatenating of water. So let's go ahead and scroll up and see what the try concatenating method does. So in the previous video, we talked about pass by value. So then a static method showing the concept of pass by value. So string is going to be concatenated to w locally, the input to this method, but it's going to be lost at the end of the method. And then so w is the string that we try to attach something onto. So accept a w, and then we say w plus equals pizza is delicious. We just concatenate those 3 words. And then we say system.out.println of works locally, but not after this, right? And then we could have a new w where the pizza thing is on top of it, but then the pizza thing is going to be lost afterwards, right? So then if we scroll back down to the main method, let's see where we're at here. So if we scroll back down to the main method, old string, we get waterfall, right? And then renewal.try concatenating of water. Well, we instructed it to print works locally, but not after this. Waterfall, pizza is delicious. So I was able to do it in the context of the static method, right? But then if you do the new string, you can see that the water variable wasn't updated, right? The static method didn't actually update the variable like after the function was called. You still get waterfall and there's no pizza is delicious. And we talked about 3 solutions to get around that. So we said we could either use an instance variable. One of the things I didn't bring up in the previous video as much as I should have is you need a constructor to initially assign that instance variable. So for your renewal class, you have a private instance variable called my_word, right? And then in the constructor, you say renewal of string s. And you could print something to the console if you want. You could say creating a new renewal object with string and then whatever the string is. And then you have to say this.myword equals s. So you would assign the instance variable to the parameter of the constructor. So to whatever input you passed in when you create the renewal object, right? But then what you would do is you would basically have another static method. So we're going to have a method called concatenate me. And then we're going to say public static void concatenate me of renewal R. So it accepts a renewal object and basically has the effect of updating the instance variable for that particular instance. You would say r.myword plus equals pizza is delicious. And it's still a static method, but it works a whole lot better than this static method that we talked about a few minutes ago, because now we're using an instance variable rather than this standalone variable that's coming into a static method, right? And so now if we go ahead and look at this solution, right, then we say water, and then so we would say old string is going to be waterfall, right? And then you could say, you could also make this an instance method without parameters. That's what we just talked about, right? This is a static method that accepts a renewal object, but you could also just have a renewal instance method that doesn't accept anything. It just acts on that object. But anyway, now you see new string, waterfall, pizza is delicious. So you can see it successfully added on that pizza is delicious to that water variable. So hopefully that's clear to you. And then we said you could also go ahead and just return something. So then there's another method up here called return concatenate. So let's go ahead and find that. So then you could have a function which accepts a string and returns another string with the pizza statement added onto it, right? So public static string return concatenate of string s. You could print something to the console every time you call the method if you want. You could say system.out.println of let's return a new string equal to original string plus the pizza thing, right? And then return s plus pizza is delicious. So now if we go ahead and scroll down, you could say string a equals renewal dot return concatenate of waterfall, and b equals return concatenate of waterfall. So since we're calling that method twice, it executes the body twice. So it's actually going to go ahead and print that statement twice, right? Let's return a new string equal to original string plus the pizza thing. Let's return a new string equal to original string plus the pizza thing, because you called the method twice. But system.out.println of b, and it just says waterfall pizza is delicious, right? Because it was able to return pizza is delicious. It was able to stick that on successfully. And that's the second approach that we talked about. Is we said in order to get over the pass by value phenomenon, you could either go ahead and update an instance variable, or you could go ahead and return a new string. You could return a new variable, and that's what we do here. And then the third solution, string my array, it's just going to be array with one value in it is waterfall. And then for each string dog food in my array, system.out.println of dog food. And so then you would just get the waterfall, right? Because that's what is shown here. So it just shows waterfall because that's the only string in the array. And we use the for each loop to iterate through it. And then we say renewal.concatenate array of my array. So then we go ahead and scroll back up. And then this is a function which accepts a string array with one element and appends text to that element. We require that the array have exactly one element. So I got a little fancy here, and I decided to throw an exception if the user passes in a string array with like more or less than one elements rather than equal to one elements. But we would say only one element in the array, please, if they pass in like 4 or something. You wouldn't really have to have that requirement, right? You could still update the first element in an array with 4 elements, but that's okay. But you could say otherwise, if age.length is 1, then you can say system.out.println of using the array technique, and then h of 0 plus equals pizza is delicious. So we could go ahead and concatenate pizza is delicious onto that particular element in the string array. So now we're going to scroll back down to our example, and we say renewal.concatenate array of my array, right? This is a static method of the renewal class. Since we're in the renewal class, you could have just said concatenate array of my array, right? You could have just said that, but that's okay. And then for int lemons equals 0, true, lemons plus equals 1. If lemons is less than my array.length, system.out.println of my array of lemons. Hopefully you can recognize that would print each of the elements in the array and then continue, right? So as long as we're less than my array.length, we're going to skip the rest of this loop and we're not going to break out. But eventually we're going to be at least the my array.length. We're going to make it to my array.length, and then we're not going to execute this code, but in fact, we're going to break out, right? So it's this break statement that gets us out of the for loop rather than the main Boolean here. But then if we print it, we say using the array technique, and then it would just say waterfall pizza is delicious. And then I think I was printing out some other examples here, so you can see 5 of the print statements, and that's why 5 other similar statements got printed to the console, but hopefully those aren't confusing, and hopefully that clarifies your understanding of pass by value and also concurrent hash maps. From Untitled 3, thanks for watching, and please subscribe.